Hello guys, welcome to this lesson. So in this lesson we want to look at a problem on identities. So it's not really a much thing. We've done a majority of this in the previous lesson. So we are just going to look at steps of proving a more complex identity. Okay, so guidelines for verifying trigonometric identities. Number one, you start with more complicated side of the equation. Okay, start with the side that is more complicated, that is very long, and that you can make substitution manipulations like addition of fraction or like applying squares and all those things. Then number two, you combine sums and differences of quotient into a single quotient. Okay, if you have sum and difference, you combine them into a single quotient. That is, if you have division that are separated, you combine them. Then you use basic trigonometric identities. So use the substitution of basic one, like tan theta is a sin theta over cos theta, uh cosec theta is 1 over sin theta, sec theta is 1 over cos theta, and cot theta is cos theta over sin theta. So all those basic substitution. So use algebraic techniques to manipulate one side of the equation until it looks like the other side. So if you are starting from the left hand side, you walk towards what you have on the right side. So you always walk toward what you have on the other side of the identity. So sometimes it is helpful to convert all trigonometric functions into sines or cosines. So if you have tried and nothing is working, you can try converting one of the side to sines or cosine and then simplify. Maybe it will look like what you have. So these are the steps, and let's see how we can apply this to prove some identity. Example 1. Verify each trigonometric identities. So we have the first one, A, sine x plus cos x squared. So we have A, sine x plus cos x all squared, okay, plus sine x minus cos x all squared. Sine x minus cos x all squared equals to 2. So you can see that if you follow our step, it says start from the complicated side. The complicated side here is the left hand side. Okay, so this is the left hand side, this is the right hand side. So we cannot prove 2 to get the left, we can only prove from the left to get the right. So we start from the left hand side. The left hand side is sine x plus cos x all squared plus sine x minus cos x all squared. Okay, and that will be equal to sine squared x, okay, plus 2 sine x cos x plus cos squared x. Okay, so if we apply simple expansion, okay, and that would also be equal to plus sine squared x minus 2 sine x cos x plus cos square x. Okay, so you can see if we do this addition, 2 sine x cos x, we cancel 2 sine x cos x, and then if we add the remaining together, we have 2 sine square x plus sine square x. That will be 2 sine square x plus cos square x plus cos square x. That will be 2 cos square x. Okay, 2 cos square x. So this is, if we factor out 2, we have sine square 2 brackets sine square x plus cos square x. Okay, and that will be 2. You know that this is Pythagoras identity, which is equals to 1, so that will be 2 times 1, which is equals to 2. Okay, which is equals to the right hand side. So we have proved this. So this is how to prove. Start from the complicated side to the simple side. B, 2 minus sine square x over cos square x, or 2 minus sine square x over cos x. 2 minus sine square x all over cos x. Okay, this is equal to sec x plus cos x. This is equals to sec x plus cos x. So which side is more complicated here? Which side is complicated? Okay, so we can say it is the left or it is the right, but they are both more complicated. So since we have the left is all in simple terms, sine and cosine, and on the right we have sec. So we consider sec to be more complicated than simple identity. So let's start proving from the right. So right hand side equals to sec x plus cos x. At least we can break down sec x into 1 over cos x plus cos x, okay? And then we can change this to a single fraction. That will be 1 plus cos square x all over cos x, right? Because the lowest common multiple is cos x. And then if we make substitution, you know that 1 plus cos square x is equal to what? 1 plus cos square x. So what does this mean? So let's try something out, okay? From our Pythagoras, note sine square x plus cos square x equals to 1, right? So cos square x equals to 1 minus sine square x. So if we make this substitution for cos square x here, we're simply going to have that 1 plus 1 minus cos square x, minus sine square x all over cos x. And then 1 plus 1 equals to 2, so that is equals to 2 minus sine square x all over cos x, which is equals to the left hand side. So you can see it's easy when you start from this side that requires substitution. When you substitute and just use algebraic simplification, you see quickly work towards the answer, and that is the answer, guys. C, 1 over cosec square x plus 1 over sec square x. C, 1 over cosec square x plus 1 over sec x equals to, what do we have here, guys? Sec square x, okay, equals to, this is sec square x equals to 1. So without arguing, the left hand side is the complicated side, so which is equals to 1 over cosec square x plus 1 over sec square x. So we start simplifying. So this is the same thing as 1 over, can you see the simplification? Let's do it this way. 1 divided by, you know that cosec square x is 1 over sine square x, right? Plus 1 divided by sec square x, that is 1 over cos square x. Are you following? That is the simplest substitution we can make for now. And then the division will turn the fraction upside down. So this is sec square x, okay, plus cos square x, okay. And then you know that this expression is always equals to 1, which is equals to the right hand side. And that is proved, guys. So very simple, very simple. Just make substitution, substitute the fundamental identities, and you can always simplify values, okay. Example 2, simplify each of the following trigonometric expressions. So we have number 1, sine x cosec x. A, sine x cosec x. So let's see which substitution can we make here. That is cosec x, which is 1 over sine x. Okay, 1 over sine x. So if we cancel out common factor, this will cancel this, and the answer is simply equals to 1. B, tan x cot x. Tan x cot x. So tan x is sine x over cos x, okay, make substitution, multiply by cot x, which is cos x over sine x, okay. If we cancel out common factors, sine x we cancel sine x, cos x we cancel cos x, and we simply have that the answer is equal to 1, okay. So So we have C, sec minus S cot X. Sec minus S cot X. Make substitution, substitute the fundamental one. So this will be 1 minus 1 over cos minus X multiplied by cot X is cos X over sine X. Okay, you know that cosine is an even function, so 1 over cos minus X will be the same thing as 1 over cos X. Okay, just cos minus X is equals to cos X multiplied by cos X all over sine X. So this cancels this, and then we have the answer. So the answer is 1 over sine X, which is equals to cosec X. So that was the simplest form of that, and this is how you can simplify identities, guys. So this is about the end of this class. So I will be posting more identities into the classroom so you can work on it and practice.